Greetings everyone. My name is Treasure. We're here at FESTO today to look at PLCs and automation production line, particularly looking at a modular production system. Modular production system consists of control panel, which is this over here, and the station itself with the different actuators and sensors, which is the top part of the station. Now the thing is the key. So I will load the key into the handling station, turn it to automatic mode, start operation. So the magazine takes out a part. The part is picked up by the handling gripper unit, delivered to the storage warehouse. So the second station, we call it a storage warehouse, which then stores it into the shelf there. The handling station usually consists of 3 parts. As I said earlier on, we have the control panel, and we have the electric drive, which is here. This is the gripper unit. So this is a double-acting cylinder that allows the extension to happen. So this, the double-acting cylinder basically extends the gripper so that the gripper will be able to pick up the part. And this is the gripper over here. And so we have a DC motor here. Sometimes instead of DC motor, we use rodless cylinders that allows the control of both directions, motions, so forward and reverse or left and right. But this is a custom handling station. You can see that it has a magazine station here. So the magazine basically takes out a part and put it onto this platform over here. That platform, we call it part available, so that when there's a part there, then the handling gripper unit will pick up that part and delivers it to the next station. We have seen the handling station. I've shown the different parts of the handling station. Now we're going to start programming the handling station. And to do this, I'm going to use an application called Cyrus. Cyrus is a simulation software that allows me to simulate hardware. I will simulate the handling station, and I will write a PLC program to control that handling station in Cyrus. Cyrus is a software which you can install in your laptop together with codices and do exactly what I'm doing to learn about PLC programming. To download Cyrus, you can go to our website. ip.festo-didactic.com is the website. So like this, and you go to applications at Cyrus. So Cyrus has system requirements, and you must just make sure that your computer meets those system requirements. And you can see they are shown here. And you can download 32-bit or 64-bit. From there, you install it. Now, at this point, Cyrus is free until end of July. So after July, this is a licensed software, so you will need to get a license. So this is an opportunity for you because obviously of the situation that we have in terms of the lockdown and COVID-19. So this is to give you a chance to learn about PLC programming. And once you've installed it, this is what it looks like. You can see that I've opened a module here, which is the handling station. You're not limited to handling station. There's many different modules that are available, such as distribution station, testing station. Many other MPS stations are available with Cyrus. So what you do is you go to File, you create new project, and when you do this, you'll select MPS, give it a name, and you will see that this table will come through, and it will allow you to select whichever MPS station you would like to add to your project. You can add multiple MPS stations, or you can just have only one MPS station. But for me, I'm going to use just one station, which is handling. These are what I'm talking about. So you can see there's a buffer station, a distribution standard, distribution conveyor, fluid press, many other. Even robotics, by the way, you can have an industrial robotic arm that you can program using Cyrus. Let us look at the how this handling station works. What I've demonstrated was a handling station with a distribution magazine or module. In my case, I'm not using distribution module, but I'm using a table here which has different parts that I'm going to put on the platform for part available on the handling station, so that the handling station will sort into the different slides. So if it's red, it's going to be sorted into the first slide. If it's black, it's going to be sorted into the second slide. Now, again, the sequence is still the same, where we put the system in automatic mode, we reset the system, put it on automatic mode, we then start the system. Okay, so I'm going to reset my model. I'm going to press run. When I press run, so there's something called EZOPC, which has to also be installed. It connects serials with codices, and as you can see, I've selected serials here and I've selected codices controller, and you can see that I have one OPC client. In this case, this is serials, and codices I also have local host which is connected. So I will first reset the system, and then I will load a red workpiece onto the platform. And you can see that on the second half of the screen, I'm showing codices. This is a program which I've already written in sequential function chart. I'm going to explain it in a moment. And then later we will program this handling station using structured text. You can see the handling gripper unit extends, picking up the red workpiece, sorting it into the first slide. I will then load the black workpiece. Then you will see that it picks it and sorts it into the second slide. How does it know that this is a red workpiece and this is not a red workpiece? So it uses an optical sensor here, which is tuned so that it detects bright objects such as the red and any other brighter object. So if I select silver, you will see that it will regard it as a bright object and sorts it into the first slide. Any object that is black or darker than black will then be sorted into the second slide. Or this sensor can be adjusted so that it regard red as a dark object and sort it into the second slide, and then silver, which is brighter than red, into the first slide. So this is something that can be customized. Looking at the PLC program, you will see that we have initial, which sets P2. Initial sets P2 because P2 it illuminates reset. So I'm going to reset the station, and I'm going to reset WOM in the PLC program or in codices. You will see that it goes to initial, and all I need to do now is to run. So to run, there's a shortcut F5, and if I also run serials, you will see that it connects to EZOPC, and at this point P1 illuminates. This shows me that I may press S4, which is the reset button. And if I press reset button, initial will, the program will jump from initial to step 0. And you can see step 0, it's going to reset all the actuators. So 1M1, 1M2 is an actuator, 2M1, these are all actuators. P1, P2, P3 are indicators or illuminators. And it's going to set 1M1. So let us say that the system was stopped while the gripper unit was aligned with the slide number 1. If I'm going to sort a part, the gripper unit must be in initial position. This is why you will see that in step 0 we set 1M1 so that it sends the rodless cylinder back to initial position, which is in line with part available. Once this happens, it waits for 1B1 and 2B1. So 1B1 is the proximity switch on the rodless cylinder at this position, which aligns with part available, while 2B1 is the sensor of the double acting cylinder on the gripper, this one over here. So if both are on, meaning that the cylinder is retracted and the gripper unit is in initial position, together we'll jump to step number 1. Let us see what happens. So I'm going to start with S4. You see it jumps to step 0, 1M1 is set to true, and P2, P3 and P4 are reset. At this point it waits for 1B1 and 1B2, which it did. You can see that it jumped to step 1 and P3 was set, and then it went to this step here. It went here. So now there's 2 possibilities here. Either not S3 and part available, or not S3, and not part available. Let me explain what this is. So S3 is the key switch. So if I turn it, you can see that it turns off. If I turn it vertical, then you can see that it becomes on. And we want it to be a NOT, because NOT simply means that it is on automatic mode. Together with part available, they should jump to step number 2, which is here. This is not the case because you can see that I don't have any part on the station. Instead, I have no part, which is why we're at step 3 and not 2. So I'm going to put a part in the slide. You can see that it jumps from 3 to step number 2. In step number 2, we wait for S1. What is S1? S1 is start button. And what is it also doing at step number 2? It is setting P1. P1 is the illuminator, start button illuminator, right? So now I will press start button. You see it jumps to step number 4. When this turns on, and it's now stuck at step number 6. We're gonna start again because something must have happened there. It shouldn't have gotten stuck there. So I'm gonna reset both applications. So we start by loading the part, reset the station, and then start. So you can see step number 6, part is sorted into the first slide, and the machine goes back to initial position. And now which step is it? Let's load a dark part and see what steps it takes. So you can see now it's at step 2. If I press start, you will see what happens between step 7 and step 8. Okay. Now let us look at and close up the PLC program. It looks a little bit complicated, but it is not. It looks complicated because you're looking at it while it's written and completed. But it's really a step procedure. We need to identify what happens in step 1, we need to identify what happens in step 2, so on and so forth. So we've looked at the PLC program for the handling station in sequential function chart, and we've pretty much understood it quite clearly. I just want to highlight on a few things before we move to structured text. You see, this simply means that if these conditions take precedence over these conditions, then the jump will happen from 6 to 7. But if these conditions take precedence over these ones, then the jump will happen from step 6 to step 8. Okay, so now, just wanted to explain that. And also this last part here, you can see that at last we are saying that step 1, so which means that after everything, this will jump to step number 1. So we're going to look at the PLC program in terms of structured text, and this is it over here. So in structured text, we have case step off, like I've explained before, and case step off is to allow us to have different steps, so that we have step number 0, and if we look at step number 0, we can see that P2 is true. P2 basically is an indicator on the reset button, so that when we start the system, reset illuminates to show that we may reset the system. And then we also have if S4. S4 is the reset button, and if we press the reset button, then the jump happens from step 0 to step number 10. And this is step number 10 over here. In step number 10, P2 turns off because now that we've pressed the reset button needs not to be illuminated anymore. So instead, we wait for S3. We say if not S3, because S3 is 1 when on manual mode, and it's 0 when it's on automatic mode, so that we can say if not S3, meaning that the system is on automatic mode, then if S4 is 1, which is the reset button. We then turn off 1M2. We turn off 2M1, we also turn off 3M1. This 1M2 is actuator to the right, and 2M1 is basically the cylinder, extension of the cylinder, while 3M1 is the gripper. Okay, so at this point in step number 10, this we can actually move it so that we don't have confusion, so that this happens before we jump to step 10. Okay, so we jump to step 10. In step 10, P2 turns off because this is to show that we have reset the system. And we wait for automatic mode. If not S3, then meaning the automatic mode, then at this point we need to eliminate P1. P1 is to indicate that the system may be started. Actually in S4, because we are resetting the system, we want 1M1 to be true, because turning 1M1 true simply means that the rodless cylinder will move to initial position. Okay, so now we can bring this also here so that we make it false after the automatic mode. Okay, now we are sure that at this point everything is at initial position. P1 is illuminated, and when P1 is illuminated, it shows that we may then press S1. S1 is the start button. If S1 and part available, which means that there's part on the platform, that is part available. This will allow us to be able to start operation. We were here. So part available is over here. Okay, so if that happens, then 1M1 becomes false. Okay, because we've already explained it in the previous step, so I can take it out from here. But what is important is that P1 must be false, because P1 is the illuminator to show that the start button may be pressed. Okay, then it jumps to step 30. At step 30, we look at the two limit switches. The first limit switch will be 1B1, which is on the rodless cylinder, while 2B1 is on the double acting cylinder to show that the cylinder is fully retracted. And when this is the conditions, 3M1, which is the gripper, opens. 2M1, which is the double acting cylinder, will extend. Then we jump to step 40. Step 40, it waits for a condition, and the condition is 2B2. 2B2 is to confirm that the cylinder is extended. And when the cylinder is extended, then 2M1, which is the double acting cylinder, a solenoid will turn off. Therefore, the cylinder will retract. Also, the gripper will turn off, which allows the gripper to close. And when the gripper is closed, it picks up the part and retract. And then we jump to step 50. I think to have it in a logical manner, we need to start with the gripper, because the gripper must close, then we must retract afterwards. Okay, then step 50, we look at that 1B1 and 2B1, which is the limit switch for the 2B1, which is the limit switch for the double acting cylinder, to verify that the cylinder is fully retracted. We can then at this point turn on 1M2. 1M2 is the solenoid valve that makes the rodless cylinder to move to the right hand side, this direction, towards this position here. At this point, we jump to step number 60. And in step 60, you can see that we look at the two conditions, which is 1B2. 1B2 is the proximity switch at the position of this first slide. So that if 1B2 and 3B1 is the cylinder, it's the sensor at the gripper, so that if the object is bright, the sensor will pick it up. So together with 1B2, they stop 1M2 so that the rodless cylinder stops at the position of the first slide. At this point, we want to extend the double acting cylinder. And when the double acting cylinder extends, what then happens is that the (2B2) will turn on, and 3M1 as a result will actually be true. 3M1 is the gripper. The gripper will open and the cylinder will retract. From there, we jump to step 80. So you can see that this is actually a step-by-step approach, which is unimaginable in ladder logic. This can only be achieved with 2 programming languages, or rather 3. This can be done with structured text, it can be done with sequential function chart, and also it can be done with statement list. I'm not saying that you cannot absolutely do it in ladder. What I'm saying is that it becomes very difficult to do it in ladder, because ladder does not have a step sequence like this. So you have to use a lot of flags, a lot of relays for that. So at this point, at step 80, we look at 2B1. In fact, I jumped something here. Step 60, there's 2 conditions. Step 60, we're looking at 1B2, which I've explained that the 3B1 will detect a part which is bright. But we also look at 1B3. 1B3 is the proximity switch at the position of the last slide, together with not 3B1. Not 3B1 is the sensor at the gripper that the part is not bright or part is dark. So those 2 conditions allows the cylinder to extend at the position of the last slide so that we can sort the dark material. From there, either one of these conditions can be true. They cannot be true altogether, both of them, because you can see that the conditions are not identical. So one of them will be true, and if that happens, then we extend the cylinder. You can see 2M1 here and 2M1 there. When the cylinder is extended, 2B2 will turn on, and when 2B2 turns on, the gripper opens, the cylinder retracts, which means that the part will then be dropped into one of those 2 slides. At this point, when the cylinder retracts, 2B1 turns on, and 1M1 is going to turn on so that the gripper unit will move to initial position. When it reaches initial position, 1M1 turns off. At this point, we have sorted the part and everything is done. So you can see outside of key step off, we have S2. If not S2, this is stop button, which means that if the stop button is not pressed, or rather is pressed, because stop button is actually normally closed. If stop button is pressed, then we force a jump to 0 so that we stop everything, which I will demonstrate. So let's go online and run this and see if it is going to work. One thing I must also emphasize on is that if you look at my configuration here, I am not using a CECC PLC because physically my computer isn't connected to any PLC, and I'm not using real hardware. I'm using virtual hardware, which means that I'll use Control Win version 3, which is the internal PLC that communicates to Cirrus via EZOPC, this application that I've explained earlier on. So I need to run this project in Codesys, and I may reset the module in Cirrus, and I may start it. Now you can see that we are at step 0 at this point. In step 0, P2 is on, and you can see that the reset button is illuminated. So I will reset the machine. After resetting the machine, start illuminates to show that now I may press the start button. But before I press the start button, the obvious thing is I must load a part into this part available platform, and I will then start the system. You can see we jumped to step 60, step 70, step 80, 90, it proceeds like that. Now I'll load a darker material, and let us see what happens with the dark material. What is important to really look at this point is step number 60. You will see that when this is at step number 60, depending on the material, either these conditions will be met or those 2 conditions will be met. I'm going to start this again so you can have a close look at step number 60. So let us see what happens with the dark material. You can see for a brief moment 3B2, I mean to say 1B3 was on, and as a result, this was regarded as a dark material. Let us see what happens with the bright material. You will see 1B2 is going to turn on, and as a result, we sort it into the slide for the bright objects. So we've looked at two programming methods or programming languages for the handling station. We looked at sequential function chart. We've also looked at structured text. My recommendation to you is try to learn structured text as best as you can. If you're struggling very much with structured text to a point where you're hopeless, I will say then go to sequential function chart. Sequential function chart is simple. I don't think that you will go wrong with it. Then perhaps in future, if you have someone that can guide you, you can then look at going back to structured text. The reason is that you're going to advance where you're going to not program small things. You're going to program big machines such as what I have in my background. And these machines are not programmed in ladder, they're not programmed in sequential function chart, they're programmed in structured text. Structured text is a very powerful programming language, and it really leads to a lot of opportunities. So I've shown in the previous lesson how to declare variables, which I didn't for this lesson, because I take that you will remember that. But just to show you, you can see that they are all declared here. So I have the different variables with the respective addresses, part available, and the outputs also. Now the question would be from you, how do I identify the inputs? Because I cannot force an input, I cannot put my hand in front of part available to see which input turns on. You can do this in serious. You go to show IO or IO monitoring, and you will see that they're actually also written here. You can see that there's part available and there's 1B1. They're showing you in terms of also the tags or the labels. So this is to make your life a lot easier to know which input or which address corresponds with each input. Addresses are not shown here. However, part available, the first variable is address 0. So we have byte 0, address byte 0, bit 0. And this is going to be part available. And this continues going up. For the outputs, you may force them. So for the outputs, here they are. I have 1M1, so I can force override to see what happens. Let us force 1M2 instead. So I just need to make 1M1 false, and then I may say override. You can see that I have forced 1M2 to turn on, and as a result, I'm able to see what 1M2 controls, and this is what you're going to need to have in your program. So this is going to be address 0, 1, 2, 3, 4, 5, and so on, going up. We've reached the end of the lesson today. Thank you very much for staying tuned in. Best of luck with using Cyrus and Codices. See you next time.